Alright everybody, we got a twin cam today here on Butt Crack Cycles. A little unusual for this channel, but as I start to take on more and more customer work, this is going to be some stuff that y'all see a little bit more often. The bike in question is a 99. It's a Road King, so it's a really early twin cam. This episode is going to be some diagnostic stuff on those early twin cam ignition systems. 99 and 2000, I believe, are the only 2 years that use both a cam sensor and a crank sensor. So we're gonna go through troubleshooting both the cam and the crank sensor. A few other little things in this video too that you'll see for like some troubleshooting guides. If you have a bike that is a crank no start, and by that I mean the electric starter engages, it spins the flywheels over, the engine cranks, you know, but it never actually fires off and runs. And this is for if you've narrowed down to where it's got good compression, which I did a compression check on this bike. It's got fuel. The carburetor will flow fuel to the engine, and it will not make spark. So full disclosure, this bike does not get fixed in this episode. The customer brought it to me in pretty poor condition. This bike was pretty rough. And it sounds like they had been working on it themselves. They replaced a voltage regulator, the crank sensor, and a coil, an ignition coil. Replaced all of that before they brought it to me. And yeah, it sounds like they kind of blew their wad as far as money before it ever even showed up here. So by the time I got it, they were out of money. And so we got to a point where it's like, hey, I've done this. I think we need to do the following. And they just said, sorry, don't have the money for it. But still, hopefully this will be useful for y'all working on an early twin cam of your own. So without any further ado, let's get to troubleshooting. All right, so here it is. Like I said, this is a 99 Road King. And it's got some shiny pink graphics on it, shiny pink Harley on the tank. Got the cheetah print on the windshield. Obviously the Road King didn't come with that fairing, so someone has added this big Electroglide style fairing. It's not actually the full Electroglide fairing. You can see if you look closely that while the Electroglide has the headlight built into the fairing, this is just a like an aftermarket fairing that's been put onto the front of this bike. And I will note that it has all of these speakers up here in the fairing and aftermarket radio sort of deal, and got a bunch of wiring running. See it running there along the frame of the bike and up into the fairing. And we've got some wiring exposed back here. Not saying that any of this is bad. Not saying that any of this is the problem. What I am saying though is that oftentimes as a mechanic, when someone brings you an electrical issue, the first thing you kind of start looking for is wires that weren't there when it left the factory. But in any event, I'm gonna throw the camera on the tripod. Let's jump right into this and get started troubleshooting. So the first thing we want to do is just verify the customer complaint. Customer states engine cranks but will not start. Customer suspects lack of spark is the reason. However you want to phrase it on your work order. But that's the first thing you always want to do when troubleshooting, right? You want to just verify the complaint. Fuel on. Hopefully there's fuel in it, you know? I actually didn't even think to check that. It's got gas in it. Give it the old sniff test, doesn't smell the best. I verified that we can at least, you see that, get a little shot of fuel out of the accelerator pump despite the real wonky accelerator cable issues that are going on here. So, key on, we're in neutral, run. Okay, engine cranks, will not start. Next we just want to check and see, is the reason that it's not starting because it doesn't have spark. So we're just going to do a very simple and easy test. We're going to put a screwdriver in the spark plug lead and just hold it, you know, real close to the fins of the cylinder. And watching to see will it jump a spark. It does not. So you see I've taken this back saddlebag, this right hand saddlebag off, and this cover off where the ignition module goes. and I've done some more testing, and basically here's where we're at. There's a white and black wire that goes to this top connector, and that is your ignition power with the key switch on and the kill switch on, and we have ignition power there. I've also ohmed from the ignition connectors on the black and white, red and white, and green and white wires down to the cam sensor, and we've got good continuity there, so that's all good. I've unplugged the bank angle sensor on the other side of the bike. Sometimes those will fault out and stop the bike from running. If you unplug them, the bike should then try and run. Basically does the same thing you all saw in that last video. It spins over, it bumps a little out the tailpipes, it spits out the carburetor, but it'll never actually try to run. I'm a little suspicious of this ignition module, but I do have a few other things that I want to check first, and I'm going to dive into this a little bit more. Take y'all with me. The next thing we want to do is just go through the parts that the customer has already installed and just verify that A, they were installed correctly, and B, that they are indeed good parts. You never just want to assume here when you're troubleshooting, especially with electrical stuff. It's possible that a part's bad just right out of the box. It's possible it was installed incorrectly and then got fried somehow. Or it's possible too that somebody just straight up lied to you. And this isn't me talking badly about anyone who brings me a bike. This is just me sharing some useful troubleshooting tips with you that I've gained over the last 15 years of turning wrenches full-time for a living. Never assume anything. The guy who brings you the bike might be a wonderful person and a pretty good mechanic, but we all screw up and parts can be bad right out of the box. So let's go behind them and check what they've done. I bet everything will check out just fine, but it's still worth checking. So the first place I'm gonna go is I've unplugged the ignition coil. I'll throw a picture on the screen of what that connector looks like. It's basically impossible to get the video camera in there. And we're gonna go from the center pin of that connector to ground with the voltmeter or multimeter set on DC volts. Then I've already got the kill switch on the handlebar set to on. I'm gonna turn the main power on. So with key switched power, we should have battery voltage there, and we do. 12.51. So we're getting good power down to the ignition coil. The next thing I want to do is just pull both of the spark plug wires loose with them still connected to the coil, and I'm going to actually ohm the coil through the spark plug wires. I don't want to say you're not supposed to do this. To get a good true ohm reading on the coil, you need to have the plug wires removed. It's kind of a pain in the butt on this bike, so I'm cheating a little bit. This will still give us a rough idea of the coil windings on that side of the coil. Coils have a secondary and a primary side. It'll also tell us, do we have a break in the spark plug wire? Basically what I'm looking at here is this is a really quick and dirty test to test both spark plug wires and one side of the ignition coil all at once. It's not perfect. It's not as accurate as testing all of these components individually, but again, this is a super quick and dirty test to just get you pointed in the right direction. This coil should have around 17,000 ohms, 17 kilo ohms, and then the ignition leads, the spark plug wires, are going to add some resistance to this, so I'm guessing we're going to see somewhere around 20 to 25,000 ohms would be my guess. Let me actually get in there good on both of them. 22.08 kilo ohms, so that's 22,000 ohms. About what I was thinking. So again, this is not a perfect test, but it does at least tell us that both of the spark plug wires have continuity to the coil, and that the coil on at least that winding is pretty close to where we want it to be. I'm going to move on from the coil from here. If we check everything else and everything else tests out good, we'll come back and actually weasel the coil out from underneath the tank and test it separately and get some more accurate readings. So I'm swapping to my cell phone real quick for this video. The next thing we want to check is the crank sensor. You can see it right there with the Harley logo and the Allen key in it. It's at the front of the engine, kind of next to the oil filter and above the voltage regulator. And the wires for it come out underneath the bike. It is these two wires right here. It's a red and black. They go into this 8-pin Deutsch connector. These wires are the wiring for the cam sensor. My customer said that his son disconnected the cam sensor on this bike because he saw online that it would run without it. That is not true. On the factory Harley ignition for these early twin cams, it needs both the cam and the crank sensor. You can bypass the crank sensor and swap to an aftermarket ECU. Something like the, the Dyna Twin Tech will run off of just the crank sensor, these two wires right here, like the later twin cams will, but these early twin cams need both to function. But right now, we're just worried about this black and red wire. So I'm gonna grab the voltmeter, go back to the regular camera, show you all how to test this. There's two tests. More wires falling in my face. There's two tests we need to do right here. Okay, so I'm gonna let y'all watch the voltmeter while we test this. And what we wanna do is use these. These are back probe spoons. What they do is you can plug them into the leads of your meter, and now you have this little small, sort of somewhat sharp tip, and you can slide it into the back of the connector. When I get it down there, I'll take a picture of you and show you how it works. This is the correct way to back probe a connector, especially Deutsch connectors, but really any connector, a back probe spoon. What you don't want to do is what I see so many guys do. They take out their old pocket knife and they skin back the insulation of the wire, and then they just shove the lead of the multimeter into that bare copper. Don't do that. Not acceptable. You also don't want to go poking little holes in the wires with like the little needle alligator clips. Don't do that either. Use an actual back probe spoon. Meter set to ohms and probed in on the red and black wires from the crank sensor. We can check it for resistance. The specification here is 1,000 ohms at 68 degrees Fahrenheit. You can see we have 882 ohms. It wasn't 68 in the shop that day. That's close enough to call this good. Next, we're going to set the meter to AC volts and spin it over and see what it makes. We should see around 4 volts of AC power here. It's usually not a real good signal, and it'll jump up and down. Like 3 volts is fine, 6 volts is fine. Roughly 4 volts of AC power when you spin it is okay here. Side note, it's always handy to keep a little notebook. I always keep a notebook when I'm troubleshooting stuff. You can write down specifications of what stuff is supposed to be, and you can write down underneath it what you actually got in your testing and troubleshooting. And this is a great way to not have to second guess yourself. And should you have to call somebody for some additional help, you can give them actual numbers instead of guessing. Okay, so we are pinned in with the back probe spoons down there on our cam position sensor, and we are across the green and white, and the black and white is where our 2 spoons are. We're back on DC volts, and we're gonna go main switch power on, key switch power on, and we've got 4.97 volts. I've got the leads swapped. It doesn't matter. The spec here is with the ignition on and the engine off, we should have 0 to 5 volts DC power, which we do. Next, we're gonna spin this thing over, and we should have between 2 and 3 volts DC power here too. Obviously, it'll have the negative in front of it. Again, the leads are swapped. It doesn't really matter. Let's see what we get. So that's kind of all over the place. I think that's worth, at the very least, pulling the cam cover off, not the whole cam chest, but the points cover essentially off, and maybe pulling this sensor out and making sure it's not damaged. It's possible that this bike has a timing chain issue or a timing chain tensioner issue, and maybe something has walked into this cam sensor and damaged it. So I pulled the points cover off. I call it the points cover. It's not actually. We know it's not. And here's your sensor. It's just held in there with one Allen key. And you can see it's kind of discolored right there. And it's been hit right there. And there's actually a little bit of metal stuck to it. So that's not looking good for the home team. So future Paul here kind of realized I left this out as I was editing this video. Basically, I called the customer and I was like, hey, I'm still really suspicious of the ignition module. I've tested the cam sensor. I know the cam sensor is bad, and it looks like the cam sensor's been hit. You might have some other engine issues going on. You might have a timing chain or a timing chain tensioner issue going on, or a camshaft issue going on. What do you want to do? You know, we could maybe try and throw a cam sensor in this, and it might get the bike running. You maybe throw a cam sensor in it, and then you still need to put an ignition module in, and then maybe that gets the bike running, and then 6 months down the road, you know, it stops running because you have some underlying cam issue or tensioner issue going on. And they basically said, well, just throw the sensor at it, and if that fixes it, great, and if not, then we're out of money. So that's what I did.
And I did want to take a quick minute and show y'all how to depin one of these connectors. So there's a center orange lock that's supposed to come out of these connectors, of these Deutsch style connectors. It's missing on this bike. Obviously the customer had been messing with it and they took it loose. And then, let's zoom you in there a little bit. And then, if I get the light right, you can kind of see it in there. There's a little black plastic lock. You kind of see that right there, those two top pins. There's a black plastic lock, and you can just gently push the plastic lock down with like a pick, or even like a little small screwdriver or Allen key if you're very careful, and push the plastic lock down away from the connector, away from the metal pin, while simultaneously pulling the wire from the backside, and you'll be able to get these out. Really pretty straightforward and simple. So then with the connector unplugged, yoink, there we go. One twin cam camshaft position sensor removed. One new one ready to go in. Alright, we've got the sensor installed. This is very simple. You just push it in there, a little light coat of oil on the O-ring so you don't cut the O-ring. Always good practice. A little grease will be fine, chapstick, whatever. Just lube it up, you know. Tighten the Allen key down, or Allen bolt rather. You basically can't screw this up. It's got a little indentation, a cutout inside of that plate right there for the sensor to go into. Got the wires hooked up and everything's all zip tied up, and those other wires that the customer had hanging, I zip tied those up for him too. So now it's time to see if we can actually start this thing. Okay, yeah, choke seems like it kind of sort of works. Key on, maybe. Oh, don't really have a functioning accelerator cable. Yeah, fine. That'll make this nice. Okay. We're in neutral. 3, 2, 1, let's go. Knock it.
So that wraps up this episode. Sorry we didn't get to wrap this one up in like a nice, neat little bow and hand you back a running fixed motorcycle, but that's just the reality of it and how it goes sometimes. Like I said at the start in the intro, finances were an issue here, and that's fine. I understand not everyone always has the money for things, but the takeaway on this, the lesson to be learned, I guess you would say, is that oftentimes if you don't know what you're doing, this ends up being more expensive to try and fool with it yourself before you take it to someone who does know what they're doing. This would have been cheaper if they just brought it to me the first time, and they probably would have been able to fix this to the point where it ran. Do I still think that maybe there was an underlying cam tensioner or cam chain issue going on? Very possible. Could we probably have just thrown an ignition module on this thing next, and that would have gotten us a running bike? Most likely. And basically, that's all that this customer wanted. It was the guy's daughter's bike. Sounds like she just wanted to go to Myrtle Beach Bike Week. That's all she wanted to do, was put this bike in a trailer, take it to Myrtle Beach Bike Week, have a bike that would run enough to go up and down the strip and go to the bars, and then that was it. That's all she cared about. And you know, it doesn't sound like fixing the timing chain issues, if there was one, was ever going to be, you know, in the budget, period. And the last thing that I gotta say, just for full disclosure here, is that this bill ended up being very little. I charged them for the part at my cost, no markup, so at my like commercial account parts cost, and 1 hour of labor and diagnostic time. I know how it is when you make a YouTube video. Everybody thinks they know everything sitting behind the keyboard, and you should have done this, you should have done that, you did this wrong, you did that wrong. I try really hard to take care of people and treat people the way I would want to be treated, even if it means I don't make as much money as maybe I should, but I understood that they were really strapped for cash here. So I tried to cut them as good of a deal as possible, got my money back in my parts, paid myself a little bit for the labor, and yeah, that's how it goes sometimes. Anyways, hopefully this was useful for someone out there in YouTube land working on an early twin cam. As always, I appreciate each and every one of you who watches this channel. See y'all next time. Bye.